Okay, so let's wrap up section 3.1 by formally talking about what is known as the XY coordinate plane. Some people call it the Cartesian plane. Some people call it the rectangular coordinate plane. It has a bunch of different names. But I'm just going to go ahead and continue to call it the XY coordinate plane. And as we've seen, basically this plane, this flat surface, if you would, that's what we mean by a plane in mathematics. We need two axes, right? I need an x-axis and I need a y-axis. Again, these are number lines. 1, 2, 3, and -1, -2, -3 for the x, and 1, 2, 3, -1, -2 for y. So there's two number lines, one representing the x value and one representing the y value. Putting them together like this, we create a flat surface, a plane. And then it turns out that every point on this plane, right, has a paired piece of data that goes with it. And we also have broken the plane up into 4 pieces. There's a lot to discuss here, right? But let's go ahead and let's talk about those 4 pieces. This quad, since it's 4, is typically known as quad 1. What's nice about this quadrant, as a matter of fact, everything I've done up to this point has been in this quadrant, is both the x and the y are positive. Many things are done in that quadrant because of that fact. In real life, lots of things are positive. And then it turns out that to go to quad 2, we don't move clockwise, we actually move counterclockwise. So here's quad 2, right? What distinguishes quad 2 is the fact that my x coordinates are now negative and my y coordinates are now positive. If we keep going in this direction, this would be quad 3, right? And this would be quad 4. Quad 3, both values are negative, right? In quad 4, x is positive, y is negative. So by orientating my two number lines for x and y in the way that I have, I've broken up my flat surface into 4 different quadrants that have their own unique features. Again, if we took a point, like let's take this point right there, that data point has 2 values associated with it, right? The x value is equal to 2 at that point, and the y value is associated with 1. Written as an ordered pair, we write that as 2, 1. X, y. X is 2, y is 1. And you can kind of get a feel why we call it the rectangular coordinate plane, because if I tried to, roughly figure out what's the x value and what's the y value, I do that, I form a rectangle. And hence, that's why we call it the rectangular coordinate plane, because as I plot point to point, like this guy right there, right, that point would be -2, +1, right? The x value is -2, the y value is 1. We end up forming little rectangles, but the rectangles themselves aren't part of the graph, and so that's why I really don't like to call it that. By the way, the reason why it's called the Cartesian plane is because the person who invented this idea, here's the person you guys can all blame, his name was René Descartes. Okay, he was a Frenchman, and he's the first one to come up with the idea, how about we take paired data, put one number line horizontally, the other number line vertically, and then plot our data on that. Some pretty famous stories behind that. And I'll let you guys Google that or YouTube it. But that's also why it's kind of a fist pump to René Descartes when we call it the Cartesian plane. But what's really happening is we have an x and a y coordinate, right? So my x coordinate tells me how far I've moved along the x-axis. My y coordinate tells me where I'm on the y-axis. And then together, right, we're going to plot a point. So it looks like that point right there is 1, -3. The x value is 1, the y value is -3. So every point in the plane has its unique x and y values. Another very special point in our xy plane is this point right there. This point is called the origin, and it has the distinct feature that both the x and the y value at that point is 0. So you can kind of get a feel that everything starts there. Okay, so when we do graphing in chapter 3 here, we're going to be graphing on the whole plane, not just in the part that we like. We're covering all our bases, all right? So some of our graphs will be here, some will be in quad 2, some will be in quad 3, some in quad 4. So we got to get used to all those areas. Okay, so to do that, let's just practice a little bit. So I'm giving you 6 pieces of paired data, and we got to go plot them. And so hopefully you guys, if you want, pause the video and try it on your own, and then you know, start the video again and watch me do it and see if you were right. But as I plot along, again, remember the first coordinate is always my x coordinate, and the second is my y. So for this first one, I'm basically telling you that x is 2 and y is 3. So here's where x is 2, here's y is 3. When these 2 points come together, it's roughly about right there. So there's the data point 2, 3. What if I reversed it? You got to be careful, because now x is 3 and y is 2. So when I go plot that data, right, here's x equal to 3, here's y equal to 2, and it seems to be falling about right there. So the order of your pair is very important. Don't mix them up, because obviously I'm in two completely different locations in my coordinate plane if I mix the x and y's. All right, x is always first, y is always second. All right, so where's -1, -2? Well, that's telling me x is -1 and y is -2. So when I come here, here's x equal to -1, and here's y equal to -2. So when they come together, it looks like they're coming together right at that point. Right? So there's -1, -2 on my graph. -1, 5. Well, in this case, x is still -1, but y is now positive. So here's x equal to -1, and there's 4, so 5 would roughly be about there. So I'm saying that -1, 5 is right there. So that's own unique spot on my xy coordinate plane. Throwing fractions, remember fractions are numbers too. So I have 3/2, -3. Well, that mixed number is 1.5. Or for those, maybe 1.5. So how do I graph that? Well, here's x, here's y. My x value is about 1.5. My y value is -3. So when I put those two coordinate pairs together, it looks like I'm roughly right there. So there's the point, 3/2, -3. So yes, we can graph fractions. As a matter of fact, the next one's on steroids. So 5/3, well, this is -1 2/3. 7/4, well, that's 1 3/4. So this is telling me my x value is at -1 2/3, and my y value is 1 3/4. So where is this point? Well, along the x-axis, right, I'm going to go 1, and then if I divvy up the next part into thirds, right, we're at about -1 2/3. The y-coordinate is 1, and then if I divvy this up into fourths, we're at 3/4. So if I put these two ideas together, right about there, looks like a good location for -5/3, 7/4. All right, and so if you were at home, hopefully you got those correct. All right, a couple more points I'd like to graph. These points are very unique because they have a 0 in them. So let's talk about the point 0, 4. And what I'm saying here is x is equal to 0 and y is equal to 4. So if I plotted that data point, here's where x is equal to 0, and right here is where y is equal to 4. So this is a point that lies on the y-axis. Pretty unique point. It'll play a huge role for us later in our work. And then, of course, not only can I have a point that's exclusively on the y-axis, but I also could have a point that's exclusive. How about that guy right there? That's exclusively on the x-axis. That data point, well, the x value is 4, and the y value, right, it's not positive or negative, it's 0, would be 4, 0. So that would be a point that lies on the x-axis. So again, be careful how you interpret your points. X is always first, y is always second. We do have points that occur on the axes, right? And then we also have every point in the plane has a unique x and y value that gives it. All right, that should wrap up our section 3.1. We are truly ready to go start graphing things like 2x plus 3y equals 12. Right? How in the world do we graph something like that? And that's pretty much where our journey is going to go next. See you guys in the next section in the next set of videos.